Geographic location, latitude and longitude, these are critical elements in locating places when you're trying to understand geographic concepts or discuss geographic places. Many people have used a grid system or an index, like this one pictured on the street index map, to find a location. So often you'll see light grid squares on one axis of a map or a document with numbers on the other axis. So we've got A to F showing here on the vertical axis, and 1 to 4 showing on the horizontal axis. And then there's a separate sheet that has the name of streets and then the index numbers where you can find those streets. So if I were to make this big enough so you could actually read it, you can see that Crooksbrook Road is in C2. Let me move that back down. So if I go to C, all the way across to C, and then over and down to 2, somewhere in this square I should be able to find Crooksbrook Road. For instance, when I was trying to find Spring Road, the street index told me that the Spring Road could be found somewhere in that grid B2. So most people are used to using an index like that. You've got two values that meet to show you where a place is. So when we're looking at geographic studies, we're using geographic coordinate systems to locate places on the globe. And this is a network or a grid of lines of latitude and longitude. So latitude would be analogous to the A, B, C, D, E, F cells going across that way, and longitude or longitude would be the same as the numbered columns going across the page that way. Latitude and longitude are based on circle geometry. So the idea that in any circle you have 360 degrees to complete the arc or the distance around a circle. If you cut that in half, you would have 180 degrees. So we can look at that kind of looking down on a circle. So here is 0 degrees, and the angle between the 0 and the 30 means that this is a 30-degree angle. Here is a 90-degree angle, and that's where the 90 degrees would be expressed on the outside of the circle. If you look at this smaller circle, the distance between 0 and 90 on this little circle is a lot shorter than the distance between 0 and 90 on the big circle. When we're talking about degrees of latitude and longitude, we're talking about a distance from one place on the outside of the globe, represented by an angle, to another place on the outside of the globe. So the latitudes, they indicate location north and south of the equator, and my equator have moved, just a little plate tectonics going on there. So the latitude and longitude, or the latitude lines, are parallel to each other. They circle the globe. The lines themselves run east and west around the globe, but what you're measuring are the distances north and the distances south, so that the North Pole is at 90 degrees from the equator. And if you could cut the Earth in half so that you're looking at the North Pole and the South Pole cutting down straight through here, 90 degrees would be straight up with the equator here. That would be a 90-degree angle. That's a lot of distance. You're walking this whole distance on the Earth's surface. 30 degrees would be an angle that is 30 degrees from the plane of the equator. That's not as far a distance. Ooh. I'm going to spell check as I go. So it's important to remember that 1 degree of latitude is about 69 miles. So if you move from the equator to 10 degrees north, you would actually be going about 690 miles. So here's 30 degrees. So if I were to walk from here to there, that would be about 690 miles. So here is the equator on Google Earth, and there is 10 degrees north of the equator, and so I'm suggesting that that would be about 690 miles. So let's go back over here so I can get that in the center, and I'm going to zoom in. So I turned on the grid, and I can see that there is the equator, and there is 11 degrees north, there's 9 degrees north, so that's 10 degrees north. And so the distance between the equator and 10 degrees north latitude should be about 690 miles. So let's use the measuring tool and see how close I can get that. So I'm going to click on the equator, and I'm going to click right here. So we could zoom way in. Okay, so that's close. So that's kind of showing that 690 miles. 1 degree. So there's 1 degree of latitude. So if I were to click at the equator, and you have to get really close here to get it pretty accurate. So I'm going to go ahead and clear that. I'm going to start here at the equator. See how accurate I can get this thing. And go up to 1 degree, which is right here. Oops, now I'm at, where did it go? This thing's jumpy today. Where am I going? Oh, that's 45 minutes. Now that's 1 minute and 30 seconds. So anyway, pretty close to 69 miles here as I get zooming in and get closer and closer. Okay, so 1 degree of latitude is 69, give or take a few. The latitude lines, again, they run east and west, but I'm measuring north and south. Latitude lines cannot be bigger than 90 because that's the North Pole and the South Pole, so 90 degrees north, 90 degrees south. Longitude measures distance east and west of a starting point called the prime meridian. So the prime meridian is 0 right here, runs from the North Pole to the South Pole, and it's divided into east longitude and west longitude. The North America is in the western hemisphere, so we're in west longitude. On the other side of the Earth, of the prime meridian, is the 180th meridian, which is the approximate location of the international date line. So halfway around is 180. So the western hemisphere runs from 0 to west 180, or 0 to negative 180, and the eastern hemisphere runs from 0 to positive 180, or 0 to 180. Now, if I measure distance between 2 or 1 degree of longitude, at the equator, it's about the same, almost 69 miles, as 1 degree of latitude. But if I measure at a different distance, you'll see that it's quite different as you go north or south from the equator. So let's pull this back up. And I'm going to go over here to Africa. Okay, so I've got a push pin at 0 degrees longitude. This is the prime meridian. And a push pin at 10 degrees east longitude. Whoops, let me zoom in a little bit. Which is somewhere over the continent of Africa. So I'm going to measure that distance in miles. And I should get something like 690, something close to that. Good. So that's the same as 1 degree, or as 10 degrees of latitude would be. But let's run that experiment up here in northern Africa between the prime meridian and 10 degrees. It's about 90 miles short. Let's run it here north of the Arctic Circle between the prime meridian and, is that 10? Yeah, and 10 degrees east. Oops, I did a 5, clear that. Let's try a path for this one. I'm going to have to do it backwards. There we go. That's only 234 miles. That's quite a bit closer together. So lines of longitude converge at the poles and get closer and closer together. So if we were to measure the distance here, clear that. That's only 63 miles between 0 and 10 degrees longitude. So we have to put that together then using these lines of latitude and longitude in order to find coordinates. So when we look at the world spread out and not in a spherical configuration, we have the northern hemisphere north of the equator, the southern hemisphere south of the equator, the western hemisphere west of the prime meridian, and the eastern hemisphere east of the prime meridian. And so you can get a blank map that shows the lines of latitude and longitude, or the graticule, and one of the best ways to kind of work through these problems is to go ahead and write the latitude increments and the longitude increments on the lines themselves. It will help you kind of find the coordinates. So if I have 3 lines below the equator and I know that I have a maximum of 90 degrees, I'm going to divide 90 by 3, which means each line is 30 degrees. So this is 30 degrees south, or negative 30, 60 degrees south, or negative 60, and that's the South Pole at negative 90, or 90 degrees south. And this is, oh, my degree sign didn't work here. That should do that, yeah. And so north of the equator is 30 degrees north, 60 degrees north, and 90 degrees north. So these are my latitude. When I record coordinates, latitude always comes first. Then this is my positive western hemisphere. And again, I've got 1, 2, 3, 4, 5, 6 lines of the graticule, 6 lines of longitude showing. So I divide 180 by 6, which means each of these needs to be 30 degrees. So 30, 60, 90, 120, 150, 180. And then in the western hemisphere, negative 30, or 30 west, negative 60, negative 90, negative 120, negative 150, and negative 180. So once I have indicated the graticule lines, then I can start to find some location points. For example, if I asked you what is the location, or what are the coordinates for the x is in the southern hemisphere, so that's the latitude, so I'm going to do that first. I've already written down my values here. fix that one again. Well, not going to get fixed today. There we go. I've written down my values, so I can just read across and say, okay, the latitude is negative 30 degrees. Now I'm going to figure out my longitude. I'm in the western hemisphere. I've got 3, 6, 9, negative 120. So my coordinates for the location X are negative 30 and minus 120. So number 1 should be really easy. If you look at 1, you're on the equator and you're on the prime meridian. So the coordinates for 1, think about what you would write down for that one. Okay, number 2, this is in the southern hemisphere again. Hey, it's on the same line as the X, so I know what that latitude needs to be. And it's in the eastern hemisphere. I can come here and know what the longitude needs to be. Number 3, okay, I am up in the northern and the western. So again, I just need to come across and read that 30 degrees north here, and then read what my graticule would be there, and the same with 4. What if I were to put this X in the center of one of these grid cells? So then I could just extrapolate and say, okay, it's in the northern hemisphere. I'm doing latitude first. It's halfway. So half of 30 is 15. So my latitude would be 15 degrees north. And my longitude, well, it's halfway between 120 and 150. So 120 plus 15 degrees would be 135. So it would be 15 degrees north latitude and negative 135 longitude. So let's hope you got, for number 1, you should have 0 degrees latitude, 0 degrees longitude. For number 2, you should have negative 30 degrees latitude and positive 30 degrees longitude. Number 3 should be positive 30 degrees latitude and negative 90 degrees longitude. And finally, number 4 should be 60 degrees latitude and 120 degrees longitude. Both of those are positive.